Good morning, Algebra 2 students. Good morning, Algebra 2 students. We're going to do this lesson on section 5.5, which is synthetic division. Synthetic division is exactly a shortcut to long division. So it does exactly the same thing as long division, but it's a way to do it faster so we can check multiple roots more efficiently. So here's our goal. We're going to use synthetic division to factor polynomials. So here's an example. We want to factor this. So we're going to use techniques that we already know and find all the possible rational roots or rational x-intercepts. So we make a list of the possible p's, which is the factors of the constants term. So that would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then make a list of all the possible q values, which is the factors of the leading coefficient. So that would be plus or minus 1 and plus or minus 2. And then all the possible p over q values is our possible x-intercepts, or possible roots. So 1 over 1, 2 over 2, 2 over 1, 3 over 1, 6 over 1. So I get all of those. And then I also have to check when I divide by 2, so I also get 1 over 2, so 1/2. And then 3 over 2, so that gives me another 1. I forgot 2 over 2 gives me 1, which I already have. And then 6 over 2 gives me 3, which I already have. All right, so this is my complete list. So let's just try one at random, which obviously I selected ahead. So let's try x equals -1. That's one of the possible rational roots. So the way synthetic division works is we set up a system like this. So draw half of a rectangle and put your 0, your root, over here in the upper left. So I'm going to try to color code this so you can keep track of where things came from. So I'm putting this root over here. All right. And then the next thing you do is you put the coefficients of the polynomial along the top. So 2, -11, -7, and 6. Now, there aren't any missing terms here, but if there was a missing term, you would have to put a 0 in or your answer would be wrong. So I have x to the third, x squared, x, and a constant term. Like, for example, if the x term was missing, you would have had to put a 0 in that position. So that's the setup. Let me also color code that. So let's see. In yellow, I'll highlight where these values came from. They were the coefficients on the polynomial. Okay. And now we bring down the first term. So the 2 goes there. And then we do -1 times 2, and that's what goes here. So -1 times 2 is -2. So I multiplied to get there. I'll try to put my operations in different colors. So multiply, that's purple, but it doesn't look very different. We'll just go with it. Oh, maybe I have blue. Try blue. So I multiplied to get that, and then I add to get this. So -11 plus -2 is -13. And then I multiply again. So I'm multiplying -13 times -1, and that gives me +13, and that goes here. So I multiplied to get that. And then I add to get this. So -7 plus 13 gives me +6. And then I multiply to get the value that goes here. So 6 times -1, that gives me -6. And I add to get here, and that gives me 0. Now it looks like we did a bunch of random steps, but we actually got a good result. So this value is always the remainder. So since we have a remainder of 0 after doing the division, that means that this was in fact a 0. So that's great, because now we're almost done. So it turns out that these values along the bottom row, as long as your remainder is 0, are the coefficients on the remaining polynomial after the factor corresponding to this is factored out. So the remaining polynomial has these coefficients. So I started with a cubic. I factored out a linear factor, meaning degree 1. So I should have a quadratic left. It's always 1 degree less. So this would be the coefficient on the first term. Since that was cubic, this would be a quadratic term, so x squared. And then negative 13x, and then plus 6. So the directions were to factor the polynomial. So I need to factor this. Now I could do this again, but since it's quadratic, I'm just going to factor it. There's not a common factor, so I'm going to use my grouping method. If you like the box method, then that's fine. You should do that. So I need values that multiply to 2 times 6, so 12, and add to negative 13. So those would be negative 12 and negative 1. And I put my middle term in, so minus 12x minus 1x plus 6, grouped into 2 groups, still addition. Factor out the greatest common factor. X minus 6, I had a moment of doubt there, but it is going to work out. Minus 1, I always take out the leading coefficient if it's negative, and then that would be x minus 6, yes, and it worked. So now I have 2x minus 1 times x minus 6, so that was factoring this quadratic. So the final factored form is 2x minus 1 times x minus 6, which I got from factoring the quadratic. And now I have to go up here and say that is a 0. So what is the factor that corresponds to that 0? So the factor that corresponds to it is always x minus this value. So x minus negative 1, so that would be x plus 1. So that's my other factor, x plus 1. Great, we did it. All right, now we're going to move on and practice one more. Same process, and now we have a quartic. Come on, focus. Okay. So we're going to make our list of possible p's and q's again, just like we did before. So the possible p's are factors of the constant term. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Nice long list. Possible values of q, leading coefficient, so plus or minus 1. So my p over q values are the same list as p, because if I divide by the 1, I get the same list. So those are all my possible values. So we're going to pick one to try. So at random, let's try x equals negative 1, which happens to be the same thing I tried before in the previous example. So we're going to try this. So I'm going to set it up the same way as before. So I'm going to slow down and remind you and try to color code it. So I draw a half a rectangle, and I put my 0 over here. So this is what I'm trying to check if it's a 0. So that value goes here. And then I take the coefficients of this polynomial, and they go along the top. And I check if there are any missing terms I need to put a 0. So exponents, 4, 3, 2, 1, 0. Okay, I'm not missing one. So my coefficients are 1, negative 5, 1, 21, and negative 18. And I'll try to color code in the same scheme as before. So these values came from the coefficients invisible 1 there, negative 5, invisible 1 here, 21, and negative 18. Alright, and then the next thing I do is I bring down that first coefficient, so I bring that down, and then I multiply 2 times negative 1, and that goes here. So I multiplied to get that, and then I add negative 5 and negative 2 to get negative 7, and then I multiply negative 7 times negative 1 to get positive 7, and I add 7 and 1 to get 8, and then I multiply 8 times negative 1, multiply to get negative 8. Why do I feel like I made a mistake? just checking. I brought down the 2 and got a 1. Silly me. I don't really want to pause it and start it over, so I'm going to get some white out. Okay, found my white out, so I'm going to start it over and actually copy the number that I brought down. So bring down the 1, that's what I had, and now I multiply 1 times negative 1 is negative 1, so that was multiply to get that, and then add 5 plus negative 1 is negative 6, and then multiply negative 6 times negative 1 is positive 6, and then add 6 plus 1 is 7. And then I'm going to multiply negative 1 times negative 7 to get negative 7. And then add to get 14. So 21 plus negative 7 is 14. And then I'm going to multiply 14 times negative 1 to get negative 14. And then I'm going to add negative 18 and negative 14 to get negative 32, which is not 0. That means this is not a root slash 0 slash x-intercept. So we made an attempt and it didn't work. But after my error, it wasn't super long, so we didn't waste a whole lot of time. So now we're going to try a different number from this list. So now let's try x equals positive 1. So I'm going to use my same system and do it again. So set up a half a rectangle. So I get my 1 here, that comes from this. And then my same leading coefficients because I didn't have any success there, so I've got to start back at the beginning. So 1, negative 5, 1, 21, negative 18. So those are my same leading coefficients. Alright, same process. So I'm going to bring down the 1, and then I'm going to multiply. 1 times 1 is 1, and I'm going to add negative 5 plus 1 and get negative 4, and then I'm going to multiply negative 4 times 1 and get negative 4, and I'm going to add 1 and negative 4 and get negative 3. And then I'm going to multiply negative 3 and 1 and get negative 3. And then I'm going to add and get 21 plus negative 3 is positive 18. And I'm going to multiply 18 times 1 is 18. And I'm going to add negative 18 and 18 and get 0. Success! This is the remainder of 0. So we successfully divided out or factored out x minus 1, our factor. So now our remaining polynomial, after factoring that out or dividing that out, we started with a quartic, so it should be 1 degree less. We factored out linear, so our degree here should be cubic, so that's x to the third. So that means we have to keep going. So now we're going to continue, and this is our remaining polynomial, which later you might not have to write down, but to be clear in the notes, is 1x to the third minus 4x squared minus 3x plus 18. Sorry about the noise. So we want to factor this further. So we might have to make a new list of p's and q's. So p is all the possible factors of the constant term. Notice it's the same as our previous list. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. So that's the p's. And the q's, q, are plus or minus 1. So this is actually the p over q possible list because dividing by 1 gives me all the same values again. So we're going to do this again to try to factor this cubic some more. Okay, so let's pick one. So let's see. Again, I chose them carefully so that I won't spend a lot of time on this. So we're going to check or pick or try or whatever. X equals 3. So again, with my same color coding system, I'm going to do 3. I'm working on this polynomial now, so it's a new one. Half rectangle, my 3 goes here. And now I copy my coefficients, these coefficients, so I have fewer of them. So 1, -4, -3, 18. There were not any missing terms. So that's these. All right. And now I bring down the first coefficient, and I do 1 times 3, so multiply, that gives me 3, add 4, -3, that gives me 1, multiply -1 times 3, and that gives me -3, add -3 and -3, that gives me -6, multiply -6 times 3, and that gives me -18, add, and that gives me 0. Yay, it worked! So that means my remaining polynomial after I divide out the 3 or factor out the x minus 3 is 1x. Now this was cubic, so this is going to be quadratic. X squared minus 1x minus 6. And since this is quadratic, we can factor it. So this factors into, it's going to be a 2 and a 3 that work. And to get -1, I need a negative on the bigger number. So that's the factors. So the final answer to this original polynomial, I'm going to have 4 factors because it was quartic. So the final factored form is going to be, x plus 2 times x minus 3. And then I had factors from earlier. So remember, my previous factors that or zeros that worked were 3 and 1. Now, I know there's a 3 or a -3 here, but we had already divided out 3 or the corresponding factor. So let's write the corresponding factor. The corresponding factor to 1, which worked, not -1, which didn't work, would be x minus the 0. So x minus 1, so that's a factor. And the corresponding factor to the 0 or root of 3 would be x minus that root, so x minus 3, so that's a factor. So I also have these 2 factors. This is the same, but it occurred again. So I have x minus 3 again, and I have x minus 1. So as we saw yesterday, this has multiplicity 2. And there it is, 1, 2, 3, 4, whoops, this has multiplicity 2. 1, 2, 3, 4 factors, which we expect when we started with degree 4 or quartic. Thank you, hope you had a good snow day.